In this video, I will show you how to use the definition of the derivative to find a formula for the derivative function. We will use the same three functions that we used in the previous video. The first one was f of x equals x squared minus 4x plus 1. The definition tells us that f prime of x is the limit as h approaches 0 of f of x plus h in parentheses minus f of x all over h. This numerator is going to be pretty full, so I may need to use two lines. We have the limit as h approaches 0 of, now remember we're going to substitute x plus h in for x everywhere we see one in parentheses. So we have x plus h squared minus 4 times x plus h plus 1. Next, we need to apply the minus to f of x. Now, that minus sign applies to the entire function, which means our entire function needs to go in parentheses. Minus, parentheses, x squared minus 4x plus 1. And this is all divided by h. Unfortunately, that numerator is going to have to get longer before it can get shorter. So let's multiply it out. The limit as h approaches 0 of x squared plus 2xh plus h squared. That's the result we get when we expand the x plus h squared. Distributing the minus 4 gives us minus 4x minus 4h, and we have the plus 1 left over at the end. Next, let's distribute the minus in front of the final set of parentheses here. That gives us minus x squared plus 4x minus 1. And remember, our denominator is still h. Let's look for things we can cancel. Here's a plus 1 and a minus 1. Those cancel. I see a minus 4x and a plus 4x, which cancel. And I see an x squared and a minus x squared, which cancel. Let's take a look at what we're left with. We have the limit as h approaches 0 of 2xh plus h squared minus 4h all over h. This is good news for us because every term in the numerator has an h in it. Let's factor it out. When we pull out an h, we're left with 2x plus h minus 4 all over h, and if we want to write it in factored form, it would be h times 1. Now that the h is pulled out of both the numerator and the denominator, we can cancel. And now computing the limit by plugging in h equals 0 gives us 2x plus 0 minus 4 over 1, or 2x minus 4. Let's move to our next function. G of x equals the square root of 3 minus x. The definition tells us g prime of x is the limit as h approaches 0 of g of x plus h minus g of x all over h. Plugging everything in gives us the limit as h approaches 0 of the square root of 3 minus parentheses x plus h. Don't forget those parentheses. Minus the square root of 3 minus x all over h. Let's simplify a little. We have the limit as h approaches 0 of the square root of 3 minus x minus h. Let me make sure my radical covers everything there. Minus the square root of 3 minus x over h. Now, if I simply try to solve this by plugging in h equals 0, the numerator will have the square root of 3 minus x minus the square root of 3 minus x, which is approaching 0, divided by h, which is approaching 0, which gives us that indeterminate form again, 0 over 0. That suggests there's some algebra we can do, and because our expression involves a sum or a difference involving a radical, I'll try multiplying the top and the bottom by the conjugate, the square root of 3 minus x minus h plus the square root of 3 minus x divided by the square root of 3 minus x minus h plus the square root of 3 minus x. Let's distribute that numerator and see what we've got. The limit as h approaches 0 of the square root of 3 minus x minus h times the square root of 3 minus x minus h is 3 minus x minus h. As in the last video, when we performed the same multiplication by the conjugate, the product of the outside terms and the product of the inside terms cancel out because they have opposite signs. So all we're left with is the product of the last terms. Since one of them is negative, we end up with negative 3 minus x. Notice that the 3 minus x is staying in parentheses because the minus applies to that whole term. This is all divided by h times the square root of 3 minus x minus h plus the square root of 3 minus x. Taking a look at the numerator, when we distribute the minus, which makes that a plus, this a minus, and this a plus, we see lots of cancellation. The 3's cancel, and the x's cancel, leaving us with simply negative 1 times h. The denominator is still h times the square root of 3 minus x minus h plus the square root of 3 minus x, and because they're factored out, the h's cancel. That leaves us with negative 1 in the numerator, and as h approaches 0, the square root of 3 minus x minus 0 plus the square root of 3 minus x in the denominator. Since 3 minus x minus 0 is the same thing as 3 minus x, we can simplify this as minus 1 over 2 times the square root of 3 minus x. That's our derivative. Let's take a look at our final function. F of x equals 1 over x plus 1. Again, the definition says that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting everything in gives us the limit as h approaches 0 of 1 over x plus h in parentheses plus 1 minus f of x, which is 1 over x plus 1 all over h. Now, as before, as h approaches 0, this fraction approaches 1 over x plus 1. This fraction is 1 over x plus 1, and they're being subtracted. So the numerator is approaching 0, the denominator is approaching 0. We have a similar situation as to the other ones, in which we expect there to be some algebra we can do to simplify. Because this expression involves fractions inside of a big fraction, I'm going to clear those denominators. To do that, I'll multiply top and bottom by what would be the common denominator, x plus h plus 1 times x plus 1. Distributing into the numerator gives us the limit as h approaches 0 of x plus h plus 1 times x plus 1 over x plus h plus 1. Factoring that out would leave us with a 1 minus x plus h plus 1 times x plus 1 over x plus 1. And if that were factored out, it would leave us with a 1 all over h times x plus h plus 1 times x plus 1. Now take a look at those fractions in the numerator. We get cancellation in both parts. In the first fraction, x plus h plus 1 cancels out. In the second, x plus 1 cancels out. The denominators that are left are both 1s, so that leaves us with the limit as h approaches 0 of x plus 1 minus x plus h plus 1, with those last three terms in parentheses, all over h times x plus h plus 1 times x plus 1. As before, we'll distribute this minus sign in the numerator. That makes it a plus on the outside and changes all the signs on the inside. Once that's distributed, we see cancellation. The x's cancel, the 1's cancel, and we're left with the limit as h approaches 0 of negative 1 times h over h times x plus h plus 1 times x plus 1. Because the h's are factored out of the numerator and the denominator, we can cancel them. And now that h is out of the denominator, we can compute the limit by plugging in h equals 0. And we have minus 1 divided by x plus 0 plus 1 times x plus 1. Since x plus 0 plus 1 is the same thing as x plus 1, we can rewrite this as minus 1 over x plus 1 in parentheses squared.